Hello everyone, we are here with the analysis of Weekly Contest 94 and we will be discussing all the three questions in this video. We'll be analyzing it, we'll be discussing the solution of all three. Beginning with the very first question, occurrences of 101, which is a basic subsequence comparing question. And then we'll be moving ahead to the next question, whether to judge or not, which is a class based question in which you have to complete the code of a class. And lastly, we'll be doing least beautiful box, which is a really interesting question, and we'll be discussing the most optimal method of solving it. So let's get into it and discuss the questions. Okay, so let's begin with the first question, occurrence of 101. As the question says, Geekina gifted Geek a number n, and since Geek is away, he asked you to count the number of times the sequence 101 occurs as a subsequence in a binary representation of n. Okay, so you just have to notice that we will be comparing 101 in assuming a string, which is a binary string, as a subsequence. Okay, we just have to give the number of times 101 is occurring in a string as a subsequence. This is the first example. Let's see. We are receiving 5 as our input. So the very first thing we have to do is we have to convert 5 into its binary representation form. For 5, it will be 101. And clearly, as we can see, 101 is only occurring a single time, right? This subsequence is only possible one time. Thus, the output that we will be returning is 1, as mentioned here. You'll get the proper understanding of the question from this example, where you have 21 as an input. So when you convert it to the binary string, it is 10101. All right. Now you have to count how many times 101 is occurring in it. Holding on to this one, we can see that we have this 01, right? One formation of 101. Then we have this 01, second formation of 101. Once this is done, let's talk about this one. Okay, so comparing with this 01 is one combination to make 101. And then uh, if we take this 10 and the last one, this is also 101, right? This is how we have four combinations of 101, and thus the answer is 4. Okay, so the very basic approach of this question will be your regular way of finding out the number of times subsequence is coming in a string. But for this particular question, because the string that we have to compare 101, the subsequence is really small, so we can come up with even more optimized ideas, right? So that we can solve this question in a more optimal way. So let's again take this string and this time apply some logic to it. Assuming we have 10101. Okay. Let's talk about 0, and with this 0, let's see with respect to this 0, what ones are coming beside it, right? So we can see, if you talk about this 0, this one is there, and we have two more ones, right? Before it, we have only one, and after it, we have two ones, correct? If we hold on these two, we can make two combinations, right? We can make 101 and this 101. If I hold on to this one, let's talk about it afterwards. First, let's just see this condition. If we are if we are holding on to this, we are able to make two, right? Isn't it that the multiplication of this? How many ones are coming previous to that, and how many ones are coming after to that? Correct? Let's take a bigger example to make it even more clearer to you. Let's take this as an example, and now let's keep this 0, and with that perspective, we'll be finding out how many 101s are coming. We can see that we have two ones previous to that and two ones after that. Okay, so when we hold on to this 10, we have two ways of doing it. when we hold on to this 1 and this 0, then again we have two ways of doing it, right? So it is basically 2 multiplied with 2, right? So this is a pattern that we have to follow, and we have to implement our approach. Okay, let's take a look at the approach. Okay, this is the algorithm that we'll be following. Let's read it carefully. Very first thing, we'll be initializing a counter. You can name it anything. We have to initialize it with 0 because that is basically counting. That will be counting how many times 101 is occurring. Okay. Then we have to traverse through the binary representation of n. You can do traversal as the way you want. If you're using Python, you can directly have a string, the binary string of it, or if you're using any other language, then you can use the right shift operator, and you can multiply 1 with the last digit to see if that is set or unset. And then we have to see, then this is where the main code comes, the main logic behind this. Whenever a 0 comes, you'll be checking every digit of it, and whenever the 0 occurs, we have to find out that how many ones are occurring before it and how many ones are occurring after it. Okay, once you have gotten both the two numbers, you have to multiply both, and then you have to add it up to the answer. Okay, this is how you will be getting to the final answer. Once you have counted it throughout the array, then that is going to be your answer, and you'll be returning it. Okay, so the very best way of implementing is could be prefix and suffix array. Let's see it with one example. um, let's take this only. Okay, this is the basic, the binary array that we have taken. Then we will talk about the prefix of it. The prefix of it would be 1 1 2 2 and 3. Okay, this is the prefix array. Then we can in a similar way we can find suffix array. It will be 1 1, then 2 2, then 3. All right, we have prefix and we have suffix. Now let's talk about, if we are talking about this 0, correct? How can we get that how many ones are coming prior to it? Okay, before it. This is the number 2. All right, if you're talking about the indices of it, if we are talking about the third index and 0 is kept there, we will be checking second index of the prefix array. Okay, and to check how many ones are after it, we'll be going to the suffix array, and we'll be checking this index, which is 4, one index after the main after the main index that we are following for a binary array. All right, this is what we will be doing. Let's also quickly take a look at its code. This is how you can implement it in Python. Let's just have a quick walkthrough. This is the way, like bin as a function, you can directly convert your number into a string. And this is how I've created 2 copies of this as prefix and suffix lists. Then I've just constructed them both. And this is the main logic. I've created one answer. I am traversing the whole integer, the whole binary string. And then I'm checking whenever I'm getting 0, I am adding to the answer the product of uh, the value that prefix has one index before and the value of the suffix that is one index after. Okay, we have already seen how we are doing it this way, and eventually we'll be returning the answer. Also, if you like to code in C++, well, this is the way you'll be doing it. Well, instead of using prefix and suffix, instead I have traversed it again here. You can do it either way that you want. If you just want to know that why we are traversing it till 63, well, you can go to the constraints of the questions. The number range that you are given, it is not going to be represented in more than 63 bits. Okay, so that is why we are traversing it in 63. And this is the way you access each and every bit. Not each and every bit, but assuming this is your binary representation and we are talking about the least significant bit. So what we will do is, if you have to check it, we will perform AND with 1, correct? And when the answer of this is 1, that means the last bit is set. And when we have to check the other bit, let's see, we have to check this bit, then we will perform one right shift in that array. That will become this, okay, after right shifting. And we can again perform and with 1, and we will be getting 0 as our answer. That means then this bit is not set. Okay, this is how we are accessing each and every bit, and we are checking that if it is 0, we have to do the thing. We have to count the number of ones on the left side, that is previous to that, and on the right side, that is after to that. And once you have gotten those in the main counter that we have initialized, we will be adding the product of both, and then we will be returning the count of it. Okay, so let's quickly see this code and how it is running. Okay, so here's the Python code for the same. Let's compile and run it. Okay, so we are getting the expected output. Let's submit that. Okay, so it is passing every test case. Talking about the complexity that it has, well, it is going to be just a second. Yes, so it is not going to be more than your O log n base 2, because you are performing a basic traversal, and when n is your number, it can be represented in log n bits. Okay, and that is how much you have to travel. That's all. So that's it for this question. Let's move to the next one. Here is the question statement of whether to judge or not. Let's read the question. It says Geek is conducting a coding event for his college students, but like Geek, his fellow mates are too much excited, and in excitement, they are making submissions too frequently. Okay, so Geek wants your help to avoid judging too frequent submissions. He has asked you to implement the class GFG, which has two functions. The first one is constructor, the other one is judge or not. Okay, these are the two functions that are already mentioned in your class, and we have to complete those. The first one is your constructor. It will be receiving an integer k, which is basically gap, and that gap states that after that much time, you can accept the next solution. Okay, let's see. Uh, let's talk about judge or not. It says that it accepts submission ID as an argument and returns true if it is required to be judged, and otherwise it returns false. Okay. So the thing is, there will be function calls like this. The very first one will be the constructor call, in which you'll be receiving an argument, an integer argument, and that is the gap. Okay, and after that much time, you can actually check the next submission. First, let's understand this question clearly. Okay, a coding contest is going on, and every user, let's assume we have 3 users, and these are making submissions too frequently. Okay, assume A has submitted at 5, B made the first submission as submission at 11, and C made it at 12. Okay, but A has very quickly made another submission. All right, 6, and very frequently he made other submission too, which is at 8. Okay, these are unit times, you can say. We are just assuming it and understanding the questions. Understanding this question, actually, one more thing. Assume the value of k that you have received is 3. Okay, so the first submission of A is at 5. This will be submitted. The next submission is at 6. This won't be allowed. Okay, why? Because you can see the difference. It is only of 1, right? And the value of k is 3. Talk about 8. When you say 8 minus 5, it will be 3. The exact value of k is 3, and we have to do more than that. Okay, it is at least k. So for at least, this will be passed. All right, just giving the example, if A would have made a solution at 7, that would have been not accepted at all as well. All right, now similarly, because we are using class, so we won't be talking about only one single you can say key or student. In this case, many of these students will be there, and they will be like simultaneously making submissions. Like, so many submissions will be coming simultaneously. Assume this has made at 13, this also has made at 13, and the next submission is at 15, and this one is making the submission at 17. So we have to handle all this. Okay, how will we do that? Well, the very first data structure that comes to mind is you can use a hash map or a dictionary. You can make keys of a student, okay, and corresponding to the value, you can keep uh, the latest submission of theirs. For the very first case, when we were talking about this, the values were 5, 11, and 12. Okay, but now let's talk about the second submission of A. It is 6. We will check that if 6 can be validated or not, or that means if that can be checked or not. We will compare it with we will compare the difference with K. If that is all right, then we will update this value, else we will let it remain as 5, because at 5 the last solution was possible. Now when if we also talk about 7, that won't be changing the value of A as well. But when we talk about 8, that will then update A from 5 to 8, because that solution can be submitted. Talking about B, we'll quickly see if there is 13. We won't be changing it because the difference will be 2, and that is not greater than or equal to K. That won't be changing it, but 15 will be. Okay. And C, we will check that the last solution was at 12. Next one is coming at 13. We won't accept that. The one after that is coming at 17. We will accept that. Okay. This is how this will be done. This is the basic thinking, the basic way of thinking that we will be implementing this question in. Okay. Also, let's see this example first. This is how you'll be getting the arguments of your uh, judge or not function. Okay, so as you can see, this is your name, and then one at the rate is given, and then this timestamp is given. So there are two things. Firstly, this is a string. We have to use a little string manipulation, and we will be separating two strings out of this. We're having the name, and we will be using the name as a key to our dictionary. Then we have this timestamp. We actually cannot subtract or deal with this timestamp very easily. So what we will do is we will convert this timestamp into one unit, or we can like for easier use, we will convert it into seconds. Okay, we'll multiply hours with 3600 and then minutes with 60, and then we'll add it all up to convert everything in seconds. So after doing that, when one string has two components and is introduced in our dictionary or hash map, whatever you want to say, so it will look something like this. Paras as the key, and corresponding, assume you have some value, some value in seconds, like this. Okay. So this is done. This is how we will be doing this question, but there are some corner cases. Assume Paras is making a submission at 2:10 p.m. Just taking a random example. And the next submission he has made is at 2:05, but of next day. Okay. Then what we have to do? In this condition, when the first submission is actually having the value greater than the last submission, okay, which is impossible if you're talking about only one day. But at this corner case, what we will do is we will add the number of seconds in one day to this timestamp, and then we will subtract and do the usual things. All right, let's see the approach to this. Okay, so we'll be just creating a dictionary, a map, and we will creating it as this name, name as the key, and time as your value. Then this is our logic. The very first thing that we'll be checking, that if name is not present in the map, okay, that means one new individual has come and he's making the submission for the very first time. So we will simply return true and add the new values to the dictionary. Okay. This is the second condition. What if the user is already present? And this is where we have to see things and we have to check things. The very first case will be the current time. That means the submission, the time that we are receiving right now, is greater than the previous time. Very simple condition. You just have to take care of the gap. If it is If the difference between these two is bigger than the gap, then means we have to update the map and we have to return true. Okay, and if this is not the case, then we'll be returning false. But what if and this false, by this false I mean if the difference is lesser than the gap, okay, then we'll be returning false. Then the next thing we have to check is if the current time is is not greater than the previous time, then what will happen? Then it means we just have seen, it means that the next day has begun, right? So we will add the time for 24 hours, converting into a second with it, and then we will do the normal thing that we were doing. We were finding the difference out. Then we will again check the difference. If it is greater than the gap, we will update the gap and we will return true, else we will be returning false. Okay, so this is the main functioning of this question, and we have to like code it in a class. Let's see the code. Okay, so this is the code in Python. So what we will be doing, what we are actually doing is, we are already given this function, the constructor, and we have made this function ourselves. What we will be doing in it, we will be taking the time as a timestamp and we will be converting it into seconds. And this is the function that we have to complete. We are just doing the thing that we have stated so far. We are doing a little string manipulation to get the name and timestamp separated. Then we are checking that if that does not exist, we'll be pushing that into the dictionary. Then we are again then we have taken two parameters, previous time and current time. The previous time will be the one that we are fetching from the created map, and the current time is going to be what we are receiving as our input, as the argument to a function, and we have changed it to seconds. Then we will be performing the calculations that we have just discussed, and as per that we will be returning true or false. Okay, if you want to see the solution for C++, here it is. We have created a map that is of a string, comma string. So this hash map will be having a string as a key and a string as a value also. The same thing that we have done in Python. And then this is the whole code for separating separating your name and timestamp. Then here we are calling this check, so that we can check the time gap and all the conditions that we have checked so far. Then we are doing the same thing. We are updating the hash map and we are returning the true value if it is possible to check that. And the last function is again the same, convert to seconds. And here we have used similar methods to convert it into second and proceed with our question. So let's see this code running. Okay, so talking about this question, here is the code of it. Let's compile and run it. Okay, so it is giving the expected output. Let's submit that and see if it is working for all the test cases. Okay, so it is successfully solved. This was a easier question compared to other two, but this is the way of checking how well you can implement functions in a class. So let's move to the next question now. Let's begin with least beautiful box. So the question says, an array of length n denotes the ID of ith ice cream Geek has bought to celebrate his birthday. Okay, now out of nowhere, he wants to divide them into different boxes, such that in each box, the ID of the ice creams can be represented as sequence of consecutive integers. Okay, sequence of consecutive integers. The beauty of box is defined as a number of ice cream present in it. Please help the geek to find an arrangement such that the beauty of the box is maximized. All right. So that means we have to do two things. We have to first create sequence of consecutive integers. Then we have to find an arrangement such that the beauty of the least beautiful box is maximized. Okay. Let's read this example. Assume you have this array given and all these are the IDs. What you have to do is you have to find out sequences. Okay, and by sequences I mean consecutive sequences. And once you have made consecutive sequences, you have to actually return what is the length of the least beautiful box. Okay, but you have to focus on maximizing its beauty. That means you have to focus on maximizing the number of chocolates it has. Okay, so the very the very first thing that to everybody's mind is, firstly we have to see that in one arranged manner, so we can sort that, sort it like this, and we will be having this as an array, right? So now we can see things in even more succinct manner. We can figure out solutions out of it, right? Now we have two things to worry about. First one, we have to see that how we are making the sequences. The second thing is, we have to see that by what length we have to arrange our smaller sequence, like, so that we can maximize the beauty of the least beautiful box. Okay, that might seem a little tricky, but let's see what we will be doing. So basically, from the beginning, we have to start constructing our sequences, right? So let's traverse this sorted array. Talking about this one, we can say that only one sequence can be formed from that, right? Which is one itself. If we have two ones, still there can be only one sequence. It could be one, one like this, and with another one, this, right? So till we are here, till the second element, we can only have um, one sequence of length 1, that is 1 itself. But when this 2 gets included, right, we can either pair up this 2 with this one or this one, right? We have to see, in general, we will be seeing that whichsoever is the smaller sequence, we will be adding up the new value to that sequence. Okay, for this condition, the value that we have right here is 2, and the value which is just one less to it, that's 1, has some already made sequences of length 1 and length 1, correct? For all the other cases, we'd be going with the length which is lesser, but for this condition, because the length is equal of both, we can choose any of these. So assume we have chosen this, and we are adding this to here. Okay, now the length of this sequence becomes 2, correct? And we have taken care till this number. Now when we see this next 2, what we can do is, we again have to do the same thing. We'll come here, we'll check that if a number which is just 1 less the current number, for us 1, have we already seen a sequence being made with 1? Yes, we already have 2 sequences being made with 1. Now we have to see that which is the one which has lesser length. This time this one. So for now, this 2 will be going to this one. Okay. Now 3 comes into the picture. Same things will happen with 3 as well. Okay, same thing will happen with 3 as well. We will be seeing that 3 minus 2, that means one number. 3 minus 1, that's 2. That means just one number less than 3, if that exists, and yes it does, and it is in a sequence. Now we have to see that what sequence is that the 2 is present in it, and it has the lesser value than the other one. So again, both the values are same. We can put 3 in any of them. Let's put 3 here. Then this sequence will become longer, and then we will be traversing the next tree. Then the next tree will be here. Eventually, doing all these things, we'll end up here. Okay, where the first sequence will be having your 5 values, and the next sequence will be having 4 values. So because we were doing this thing, we were adding the next value that is coming to the one list which has lesser length. Okay, thus we have taken care of maximizing the least beautiful box. All right, and eventually we have to return this 4 as our output. Okay, it might not seem clear yet, but let's see the code of it and the approach of it, and we will again try to dry run that, and then you'd be having a better understanding of it. Okay, let's take a look at the approach. The very first thing that we have already discussed is sorting the array. Then what we will do is we'll try to construct the sequence from the beginning of the array that we have just seen, from the beginning to the end. Then we'll be keeping a count of what length sequence can be made till the current element. Okay, if you have this long array and we are standing here at this position, we will see that till now of what lengths sequences can be made. Okay, there could be multiple sequences. Assume there are so many numbers and we have 6 sequences, and we have to see of of all those 6 sequences what length they are. Okay, we have to keep track of these. Again, then we have to maintain the track using dictionary, because because again what we will be doing is we'll be keeping the sequence. We'll be checking that if with that number a sequence is being made, and we'll be keeping how much length it is being made, right? So we have to deal with the data structure, which is kind of key and key and value pair. So it'd be using dictionary or a hash map, you can say. All right, and this time we'll be having the keys as the value, or you can say the IDs that we have in our array, and on the other side we'll be using a heap, because every time you might have noticed we were finding we were inserting the new element in the sequence which has a lesser value. Because we have to access the lesser value every next time, what we will use is, instead of finding it out every time, we will use a heap, so that we are using less time. Working will be, we have to maximize the current smallest sequence. Okay, we have already seen that. What we have to do is we have to maximize the current smallest sequence. Let's see the code for it, and we'll be taking a deeper look into it, don't worry. Let's dry run this code with one of the examples. Okay, so let's begin with the dry run. As you can see, the very first thing that we are doing is sorting the array. Let's sort that. After sorting, we will have an array like this, right? Okay. Next thing that we are doing is we are creating a dictionary or a hash map like this. Now we are traversing our whole array. Okay. And here are all the conditions that we were talking about, and now we will see how these are working actually. Okay. So we are using a combination of dictionary and hash and heaps here. So we'll be making keys with the values that we are encountering in our array, and then and to the corresponding of that we'll be creating heaps, and those heap will be helping us remember that of what length our sequences are made till now, and for adding up the new element, which sequence we'll be picking. We will basically be picking the sequence with a smaller length. So when we are using heap, at the top of the heap, whenever we pop, what will happen? We'll be receiving the length which is the least. Okay. So let's run it. For the very first time, we'd been encountering this 1. Okay, now we'll be checking that if one value less than 1 is existing in our array, in our dictionary. So for this time, because the dictionary is empty, this won't be happening. We'll jump to this else. We were checking for one value less, and inside here we are checking for the exact value. That means 1. If 1 is existing in a dictionary, well, it is not already existing in the dictionary, so we'll follow this else, and we will create a new key, this one, and we will also have one empty list which will be acting as our heap now, and we are actually pushing one value inside this heap, which actually tells that with this one only we can only have one sequence which is going to be of one length. Okay, going to the next value, this one, what will happen? We will check this, that does 0 exist in the sequence? Well, it does not. We'll jump to this if, and then when we see the we will jump to this else, and then when we see this if, what happens is we are now able to find 1, and it is already present inside the dictionary. What we'll do is we'll again add one more 1 to our heap. So the heap will be like something this 1 comma 1. All right. Now what these two ones denote? These two ones denote that two subsequence of one length can be formed till now. Okay. Till now, when we are here in our array, two subsequence can be formed which are of 1 and 1 length. Okay, let's keep on going for the further values. Okay, we have 2 here this time. Now we will try seeing this. What is happening? We are seeing that just one value less than 2, if that exists in a dictionary or not. Well, yes, this time 1 is existing in a dictionary. What we will do, we will go inside here, then we will check that even if it is existing as a key, does it have any list corresponding to it? Well, this time we do have this list corresponding to 1. Inside it, we will see that, okay, firstly what we have to do is, we have to pop one value out of this heap, because both the values are same. One will be popped, and that will be, we'll be keeping that inside num. Now what we are doing, that we are checking that if ARRI, by that we mean 2, that 2 is in the dictionary itself. Well, this time no, we don't have 2 inside dictionary. What we will do is we will create a new key. Okay, we'll create a new key, and corresponding to it we will create a new list. We'll make that list a heap, and we will insert num plus 1 value. Num was 1, but now num has become 2. What does that denote? Till 2 we can have, okay, including this 2, that means till 2 we can have two subsequences. We can have two sequences, sorry, we can have one sequence but of length 2. Okay, that is a little confusing, but let's keep on moving. We are now here at this 2. What we will do is we will again check all the things. Yes, one value less than it exists inside it. Yep, it 1 actually has list left. Okay, then again we are going to do the same thing, and this time 2 is already existing, right? So we need not to create a new list and add it, but we'll be doing heap push again with num plus 1. This time also num was this one which was popped out of the first list, and by adding 1 we'll make 2, and we'll again insert it here. Okay, now this is the current situation. We have to talk about this. We have two sequences now, both of 2 lengths. Okay, let's keep it quick. We're talking about 3. We will check that if 2 exists. Yes, 2 exists. Does 2 have one list associated with it? It has to. So what we'll do is we'll create a new key for 3. We will pop this 2, and we will increase the value of num, and we'll add it here, right? And the work of this iteration will be done. Talking about this 3, again we will do this. We will do the same thing. We will check with this 2 that if one, if list corresponding to 2 exists. Yes, it does. So we'll pop it. We will add one more value to we will add 1 to 2. We'll make it 3, and we will add that to the heap associated with 3 here. Okay, so now this is the situation. Till here we have 2 sequences, both of 3 length, which are, if you just see, which are 1 2 3 and 1 2 3. Okay, these are the two sequences that we are talking about till here. Once when 4 gets introduced, again we will check one value less than 4 3. Yes, it exists in a dictionary. What we will do is we will create a and yes, one list associated to our 3 is there. So we will pop it out, and then we will make a key make a new key which is 4 Corresponding to it, we'll create a heap. We will add one value to it, which is 4, which will then become 4. And now the current situation is like this. So we have done this. Okay, we have one sequence of length 4, this, and we have one sequence of length 3, this. All right, coming to this 4 now. Again, 3 exists, one list corresponding to 3 exists still. And if this is the situation, we will pop this from that heap, and then we will add 1 to it. We'll make it 4, and we will insert that in the heap corresponding to 4 here. All right, we have now 4, 4, and we will be keeping this 4 here. Okay, this is just for reference. So till now, everything is going smoothly. Now let's talk about this 5. When 5 comes into the picture, we can see 4 exists, and a list corresponding to 4th is there, but we have to make a new key for 5. We will insert 5 here, because we'll be popping 1 4 from here. Okay, and we'll be adding 1 to it. So this is the current scenario. 5 will be added to one of those. This is the current scenario. We have this dictionary formed, and the traversal is over. Okay, so a big chunk of question is over. Now what we have to do with this dictionary? We have to check all the keys. Okay, we have to check all the keys, and then we have to see the corresponding values for lengths. And now we have to return the least length that exists. Okay, so what we are doing for that is, we're just checking, we are traversing this dictionary or map, you can say. We're checking that if that key has one list associated with it, we will pop that pop that list, we will pop that heap, and all those values we will first keep that inside a variable, and then we will having our main answer, and we will be keeping the minimum of all in that. Okay, and eventually we'll be returning minimum of that. This question will be even more clear to you if you have not yet gotten it. You can rewatch the video, and you can try by yourself the next sample case that you have, and you'll have even better understanding of it. Let's run this question now. So here is the code. Let's run it. Okay, it is giving the expected output. Let's submit that. Okay, so it is successfully getting solved. Okay, so that's the end of this analysis. I hope this was very helpful for you. Thank you so much.